Okay, guys, quick review of our solving radical equations. 4 quick steps. First one, remember you want to isolate a single radical on one side of the equation. So when you square both sides, which is what we're going to do in step 2, or take it to whatever power you need to, it will eliminate one set of radicals. So then you're going to keep on doing that until you don't have any radicals remaining. So again, isolate a radical, take it to that power of that index. In our case, we're only going to be squaring them. And then keep doing that until all the radicals are gone. And then you're going to solve the remaining equation. And then after that, you're going to check the solutions back into the original equation. Because remember, as we discussed, when you start squaring things, occasionally extra answers will be created, which obviously are not very, very helpful in terms of coming up with the right answers. So 2 examples for you. One that involves a single radical. Again, remember the first rule, and this is very important. Again, not that you can't do it this way, but it's, I would say, vital. Get the radical by itself. So I'm going to move the -2. So I have the square root of 8x plus 1 is equal to x plus 2. When you square these, you're going to square entire sides. You don't square the parts. So when we square this, this is going to be multiplied out. If you need to write it out as x plus 2 times x plus 2, do that. I did tell you that we needed to, that ideally you should know the shortcut for squaring this, which is, again, you square the first term, you double the product. So in this case, 2 times x is 2x, double it to 4x, and then you're going to square the last term. Okay, but if that stumps you, write it out with the 2 binomials next to each other. We don't have any more radicals, so we're going to go ahead and solve this. So we're going to come up with x squared minus 4x plus 3 when we move everything over to the other side. And then you can solve this however you want. Factor it, complete the square, quadratic equation. This is going to turn out, factoring is pretty easy because you can use -3 and -1. So my 2 potential solutions could either be 1 or 3. So now what we're going to do is we're going to come back up here and check these answers to see if it makes sense. So check number 1. Actually, you know what? Let me do it this way. Yellow, come on, there we go. I'm going to clone this. Bring this down here. So what we're going to do next is we're going to check 1 and 3 in this equation. So initially we've got the square root of, I'm going to, for x equals 1. So 1 plus 1 minus 2, hello, come on. And is that equal to 1? It looks like an 8. Let me fix that. So here I then, this is square root of 9, which is 3, minus 2, that is equal to 1. Woohoo! So that's one of my solutions. We're going to check the same thing over here for 3. Is the square root of 24 plus 1 minus 2 going to equal 3? So we have 5 minus 2. Again, square root of 25 is 5. So that's equal to 3. Woohoo! That one works. So this is one of the cases where we don't actually have an extra solution. Both solutions work. And again, as a review, if we come back up here, what's going on here? We are essentially intersecting this radical with the line y equals x. And so again, if we're going to graph that out, we've got this equation here. We've got a line, something like, probably like this. And you've got this line y equals x crossing here. So again, 2 solutions is not out of the realm of possibility. The other one I want to do example-wise is where you have 2 radicals. And again, isolate one of the radicals. The 2x square root is 2x plus 6 is already over here by itself. So now when you square this, you're going to square both sides. And this is where things get a little messy. And again, why you want to try to keep it as simple as possible. Right side, 2x plus 6. No problem there. Square root of anything squared is just going to be whatever you're dealing with. Over here, just like before, we're going to square the first term. This whole radical is acting as the first term, so that's going to be x plus 2. We're going to double this product, so that means we're going to go 2 times whatever 1 times square root of x, square root of the quantity of x plus 2 is. So that's going to be 2 square root of x plus 2. And then we're going to go plus 1 over here. Now notice, we still have a radical here. That's okay. we're going to go back to the system. So we're going to say, okay, we got to move everything. We're going to isolate the radical. So I'm going to move this and this to the other side. So that means I'm going to have to subtract off an x and subtract off a 3. So then we've got 2 square root of x plus 2 is equal to, oh, sorry, lost my pen, equals x plus 3. Now, I said in class, if you wanted to, you could divide through by 2 here. I only recommended, however, doing it if you could divide everything evenly, because otherwise you're going to be dealing with fractions. And sometimes it's easier to do that after the fact, because then you don't have to worry about rationalizing the denominators. So we're going to square all of this. So this side is going to get squared. This side is going to become squared. So the right-hand side, because I'm squaring this, square the terms, double their product, square the ending. This side over here, you have to square both parts. The 2 becomes 4 squared, or 2 squared, which is 4, and then I get x plus 2, if the smart board will allow me to do that without trying to recognize my handwriting. All right, so x plus 2. So I get 4x plus 8. So then this, if I move everything over to one side, this will become x squared plus 2x plus 1. And then we're almost done. This factors out to be, oh, gee, nothing. No, I take it back. It's actually x plus 1 quantity squared, because the factors of 1 times 1 is 1, 1 plus 1 is 2. So that means that x is going to equal -1. It actually happens twice. Got to check that back up here in the original equation. So I'm going to go 2 times 1 plus 2. It's going to be a -1 plus 2. Somehow it doesn't like me writing 2's. Disappointing. And is that the same thing as a -1 plus 3? Hello? Oops. Squared. And from there, sorry, so then this is going to become 2 square root of 1. Is that the same thing as equal to 2 squared? And so square root of 1 is 1, so this becomes 2, this has become 4. Unless I made a mistake, that's not equal, so that means that this one would actually have a null set. So again, just because you come up with answers that seem to work doesn't necessarily mean that they're always going to work. So with that being said, have a good weekend, and we'll talk to you later.